IoT and specifically industrial IoT and kind of computer vision, AR, VR related areas. I'd like to highlight one of our companies, Neva, which is essentially roboticizing the front office, so the support desk and the service desk, using NLP and search and deep learning technologies. So if you are interested, we would really love to hear from you if you're interested in a job. The hashtag for today's event is Hive Data, so if you're tweeting. I'm excited to have Doug Cutting with us today. Doug was first introduced to us by Lance Riddell, who Lance was at the Hive as CTO before Mohan, and started a company called Kosei that was sold to Pinterest, along with Yuri Leskovic actually there. And so Doug needs no introduction, at least not by me. He's the founder and chief architect of Cloudera. He's been chairman of the Apache Software Foundation, has worked on a number of different technologies, Lucene, Nudge, Avro, and of course Hadoop, and has worked in a number of places, including along with Lance at Yahoo. Lance and Nigel out there at Yahoo. So with that, I'd like to welcome Doug. Doug will speak for about 40 minutes, and so please hold your questions till after that, and he'll take all your questions. Thank you.
Thank you very much. It's a pleasure to be here. I want to keep this informal, and I'm just going to, I don't have I'm not going to show you a deck with a lot of detailed bullets, but rather just reflect a little on how Hadoop came to be. We've got some of the other folks who helped in the early days, and also talk a little about how what it's become and how it's evolving, and what we might expect in the coming years. So first, 10 years is quite a while, and if actually the roots of the project are older than that. The first meetup was probably held 9 years ago, so from the beginning we've been doing these things and getting folks involved. The first one was in Palo Alto, a good deal smaller than this group here tonight. Now we've got hundreds of meetup groups around the world. We've got dozens of conferences around the world. Many companies around this. It's really grown into quite a thing. It's easy to say, it was all Hadoop, but really I think Hadoop is just a seed of something, and was a spark at the right moment that helped ignite what we're now seeing. I think there are a lot of trends that really fed in. And I think all those trends are long-term trends, are solid trends. And I don't think so. People frequently ask, is this the hype bubble? Are we at peak Hadoop yet? Depending on what you mean by Hadoop, for most meetings of it, I'd say no. We're a long ways from that. We're still at the very early stages. And some people mean the very specific technologies that are Apache Hadoop. And we may or may not be at the peak of that, but that's not very interesting. What's more interesting is to look at the broader thing. So what is this broader thing? I think we've got these long-term trends, like advancements in hardware, driven by Moore's Law and other related things, that has given us this incredibly large quantity of hardware for a less and less money each year. You think about it, the percentage of a company's revenue that it can spend on computation, if they say you spend a fixed percentage of your revenue on computation, you're able to do more and more computation each year, and more storage. So you don't have to increase your spending on IT, but you can do more stuff. And people are doing more stuff. That's the amazing thing, is the way this is spread through industries. If we think back 10 years ago, 20 years ago, computation was relatively isolated within companies, within industries. Maybe accounting had a system, maybe inventory had a system, a few narrow things like this, doing specific functions. And there might have been a few businesses that were really built around IT. Notably the web, built businesses that were entirely online, entirely existed on computers. But most companies, at their core, really weren't using computation. That's changing, and that's really changed over the past decade, and it's continuing to change rapidly. Almost every, I'd say, traditional enterprise is becoming predominantly driven by data and by IT systems. Banking, insurance, telecoms, manufacturing, retail. I'm amazed by some of the places that I visit. One that tickled me was Caterpillar Tractor, as now instrumenting all of the machines that it ships around the world with sensors. Hundreds of sensors recording 100 times a second readings about what's going on there, what the pressure is, what the angle is, and sending those all back to headquarters in Peoria, where they can then understand how their customers are using their products, predict when products might fail, and then use that to improve their products, to deliver service before something fails and shuts down an operation by blocking a road, say. And we see this again and again. We see this in healthcare. We see this in railways. We see this in utilities. Things we don't think of as being IT-driven industries are becoming them. And I think really we're seeing IT become the fundamental driver of the economy in this century. And that's through data. So we've got this pent-up demand to be able to analyze data. And we had the hardware that we could do it with, getting cheaper and cheaper. We needed some software, and Hadoop arrived, luckily, more or less by chance, at the right time to take advantage of this, for people to pick up on these trends. I happen to be working on search software. I was working on a project called Nutch. I've worked on search software at various companies for 15 or so years before that. I wrote a search engine called Lucene, which I made open source in 2000, and learned the power of open source to take technology and spread it very rapidly and make it a standard. And to, with far fewer resources, make something more popular, more useful than commercial alternatives. So it was a wonderful tool that I discovered in open source there with Lucene. So a few years later, working on a web search engine, trying to build a crawler and a full web search engine as open source, a project called Nutch. We read some papers from Google about the way they were doing things, and they described their storage system, GFS, the Google file system, and the execution engine that ran on top of it, called MapReduce. And we realized that these would be wonderful tools for everyone to use, and that they were at that point only available to people within Google. And so it struck me as an opportunity that we could implement these as open source and use them in Nutch, in our search project, where we needed them badly. But moreover, others might find uses for them in other places, because they were neat techniques. What was neat about them was that they let folks run really big computations over really big data sets on really cheap hardware. And this was a big change. What you had in those days, and still to some degree had, is the database industry, which ran on very expensive hardware with very expensive software, and scaled for a while, but not really indefinitely. Not to lots of processors, not to thousands of processors and thousands of hard drives very easily. And could it really use all of those processors and all of those hard drives to process in parallel together effectively? Whereas these approaches that Google described could. So anyway, this seemed like an opportunity. Mike Caffarella and I, in around 2004, 2005, implemented these ideas of Google's within Nutch, and they worked badly. We realized it was a harder problem than we thought to build distributed systems and make them reliable. There's so many more ways that a distributed system could fail. So we needed help. And in 2006, I joined Yahoo and worked with Nigel, who's here, and Milind, who's here, and a team of others. And within a year or two, really brought this technology. We renamed it in 2006 Hadoop, after my son's little stuffed yellow elephant. True story. We, within a couple of years, got it to the point where it really was reliable and really did deliver on this promise of giving people scalable computing that ran on affordable hardware and was very general purpose. And it started to take off. Now, I had always worked for Silicon Valley companies, web companies, and PC companies, and so on. And it's kind of a separate universe from the IT companies that sold software to enterprises, that build the database systems. I think it's sort of a hacker community is what I came out of. And that we were using open source pretty widely and was accepted as a way of doing things, to share software and collaborate and evolve things fairly quickly, incorporate new methodologies. Whereas enterprise software was, frankly, pretty stodgy. Didn't change very quickly, and wasn't respected all that much. There were really two separate families of software development going on in those days. And I was firmly in one camp. And so we had this stuff running, and it started to get picked up by people in my camp, by people at Facebook, by people at LinkedIn, by people at Twitter, and started to really become a standard. And I sort of thought, okay, we're done. I've achieved my ambition here, which is to build a general purpose implementation in open source of Google's ideas. There were other people, though, who saw greater opportunity in this. They realized that industries were going through digital transformations, that more and more companies would need this in the coming years, but they weren't ready to pick up this open source software and run with it in the way that a Facebook or a LinkedIn or a Twitter would. So they needed help. They needed a vendor. So in 2008, I guess it was, Cloudera was founded to try to fill in this gap, figure out what is it that we need to add to this to make it easy for banks and telecoms and insurance companies and governments to install and run this software and build on it. And so that's how Cloudera got founded there. I didn't believe this would happen. I didn't believe that in 2008 when Cloudera was founded that these kind of institutions would ever use the kind of software that I had worked on. But after a year or so, I thought, what the heck? There clearly were some people who did believe this. They were smart people, the people I liked, I respected them. So I joined Cloudera in 2009, and we've had a pretty good run of it so far. Hadoop has changed a lot in the years since then. So we started out, as I mentioned, with just this distributed file system and this MapReduce engine, which was a game changer, but it's pretty primitive. It's hard to use, hard to program using the MapReduce APIs. Gradually, through the years, people have come and added more things on top of Hadoop and around it, and made it easier and easier, and made it fulfill more and more functions. Initially, we had things like Hive, which lets you run SQL queries, batch SQL, using MapReduce as the engine underneath, over files stored in HDFS. opened up these tools, this affordability and scalability to a much wider audience, people who could write SQL queries. We started to see different things besides batch computing. An online NoSQL storage engine in the form of am I blanking on the name here? What's it called? Bigtable? No, not Bigtable. What do we call it? HBase. HBase. Thank you, Nigel. I don't know that. And so on down the line. Search engines in Solar Cloud now runs on Hadoop, and we're starting to see something even more interesting. I think for the long term is basic elements of the stack getting replaced. Spark appeared, maybe probably originally 4 or 5 years ago, gradually got to the point people found it was interesting to use, and it's gotten now embraced and supported, become one of those popular projects out there. And it is a much better API than MapReduce, much easier to use for batch computing, but also isn't just batch, supports online computations, streaming computations. Spark can use the memory of a cluster much more effectively, so that if you're running an iterative algorithm, it can keep the intermediate data in memory, which causes things to run maybe 100 times faster in some cases. So it's a much better execution engine. And the community has adopted it. Folks out in companies, folks like you out in companies are starting to use Hadoop running on, Spark running on top of HDFS and to process their data instead of MapReduce. And this is a wonderful thing, and it really shows that this system evolves very quickly. That no longer are we in a world where the vendor controls the platform. If you think about the rate that the SQL ecosystem evolved, it was very slow. Oracle was founded in what, 82? 77, okay. And how much did, in a fundamental way, did their product change over time? And it's changed a lot, granted, and it's gotten better and gotten more full-featured and so on. But it's been a SQL database. It hasn't been a fundamental reinvention of its basic operation. And yet we're seeing those sort of fundamental reinventions in the Hadoop space in less than 10 years. And I think we're going to continue to see this kind of improvement that comes from this method of control, this lack of control. There is no central control of the Hadoop platform. Rather, what we see is Darwinian evolution. We have people creating new projects. Spark is a great example that came out of UC Berkeley as a sort of a random mutation. People try it. Over time, they find that this is actually a useful mutation, unlike 6 or 8 other ones, which we no longer remember. And it becomes the successful one that overtakes and becomes the successor. And we see this. Kafka is now a huge new arrival on the scene, being used widely, came out of LinkedIn. And I think this is the new pattern, that we have an ecosystem that is controlled by the users, largely. The people develop and adopt technologies independently. At Cloudera, we have a lot of customers, and most of them build predominantly on the set of technologies that we support, but also they will frequently try things out when they need something that we don't provide, that there isn't a good supported solution for yet. They'll try something that's experimental and unsupported. And then they'll tell us what works. And when we have enough people telling us, you need to support this, then we can add it into the platform. So we work with customers to try to help figure out what is the next version of this platform. It's a very different approach. It's enabled by open source because as a vendor, vendors can no longer rely on you necessarily staying with them because you can use the software for free. Rather, they need to convince you with each cycle that they're providing value that you need again and again. So it's a very different dynamic between vendors and customers, and also that's driving the technology. So as we look forward, I really think it's a very exciting time. We've got now a platform which is much better than the prior generations we had. Not only is it less expensive to do processing and storage, it's more functional. You can not just do SQL processing with a variety of different SQL engines, but you can do search, you can do machine learning, you can do a NoSQL store. You have all these options of different things you can do on a shared repository of data. And so this encourages a better style of application development. You don't hear about people using sort of the old waterfall development where you up front sort of find out the requirements, come up with a design, implement it, and then deploy it, and never move backwards. It's a very rigid methodology, and if you make a mistake during the design phase, you're stuck with that to a large degree. It creates pretty inflexible systems. Rather, we're now in a world where folks can easily experiment. The tools encourage and support experimentation. You've got all your data online. You've got it all online in one place. You can try different things out, find something that works through an iterative process, deploy it into production, and then continue to improve it. You can afford to save the raw data. You don't need to devise a schema up front and transform all the data into it before you store it. Rather, you can store it in the raw form and either transform it on the fly or save transformed versions that you can easily recreate should you decide to change your transformations. Much more flexible system, a much better way to build applications, frankly. It's very difficult to get things right the first time. It's much easier to get something that sort of works, demonstrate its utility, and then iterate, improving it. Do A to B experiments. Try 2 different versions. See which one works better. And continually improve over time. So I think you are now in a better world for developing data systems, for all the reasons I just outlined. And moreover, because as I described the way this ecosystem is structured, things are going to continue to get better. You're going to continue to see new tools arrive that make things easier. There's also advances on other fronts, besides just the software technology. And we're continuing to see some fundamental advances in hardware. I'm very excited about all of the memory technologies that we're going to see arrive in the next year or so. Intel has 3D Crosspoint, and I think other hardware vendors are working on similar things. And this is memory that operates at roughly the speed of DRAM, maybe a little bit slower, but not much. Probably 1,000 times faster than flash, but at roughly the price of flash. And this means we're going to have a lot more memory in our clusters, and no longer will our primary bottleneck be I/O. And for decades, we've been building systems, designing everything around I/O being a bottleneck and memory being precious. And that will change, I think, fundamentally in the next few years. And that will change the kinds of systems we build, the kinds of systems we can deploy when we start using these new memory technologies. Folks are moving to the cloud more and more, which also, again, changes the technology stack. You start to think about deploying things dynamically, elastically, and having a cluster that you deploy for a particular query, a particular job that may not be long-lived. And start to think about the whole business of software changes when things are built by the hour, by the minute, rather than in licensing revenue. So it's changing the business model, the relationship between software vendors and customers, again, will fundamentally change with that. So, and I think the biggest thing that I think we can expect to see is all of you getting involved. in the old world, I think there was very little development of software by users. And we regularly see at Cloudera our customers contributing patches, fixes, even new software modules. Now people say, well, you know, the vast majority don't. And that's true, and that's always true. That's what makes this model viable, is that 99% of the people aren't writing the software, they're just running it. That makes things efficient. But the people who are developing it aren't all in one place. They are spread out across the whole industry, and that adds up. And it also validates the use in that people help build the systems that work best for them. So let's see, anything else I want to add? Oh, some of the risks I think we run are several. They're mostly not technical. Mostly what I've been talking about is technology, and the technology is very exciting. I think there's a lot of good stuff coming, but there are some risks out there that we need to be aware of. One is the social risk within institutions. It's hard to get people to change and to adopt new things, even when they are better. And I think we see this, that a lot of companies resist bringing on these technologies, and the companies suffer, and their competitors might adopt them more readily. So it's really important that we make these technologies easier to use, that we work a lot on training and bringing people up to speed, and that we all help to transform organizations. Many times adopting new technologies requires a change in the organization as you move towards more self-serve tools and move towards combining storage and computation and removing silos. It requires organizations to adapt, which takes time, and I think is more than anything else gating the adoption of these technologies. I also think it's a risk we run is not respecting people's privacy sufficiently. I think we're still a little bit in the Wild West days of data technology, where people aren't respecting the data that they store, and that it concerns real people, and we don't have best practices around this. People aren't thinking enough about whether the systems they build are ethical, and I think we need to get ahead of this soon, or else much of what we could do will be prohibited. We'll see that the systems which could provide great utility in healthcare, in education, in government, might not be legal to build. And so we need to make sure that we build trust within users, within society, for the systems we build. So I hope that makes sense to all of you. I encourage you all to look and read some about data ethics and think about the systems you're building and whether there are things that you would like to use and that you would like to have stored about you. So with that, I'm gonna pause. I think I've talked enough, probably too much, and I really want to hear your questions. I think this is the best part of the evening. We got to find out not just what I think Hadoop's going to be in 10 years, but what you think.
And so, Milind, if we can just stand in line here so that we can also record the questions. Thank you. Just behind the camera.
Thanks, Doug. I think that was a great, and thanks for mentioning me. So one of the things that I basically see, MapReduce, which was widely abused by the database researchers, and there are some of those here. So Spark, though, right, claims to do things that I think are not. I mean, MapReduce focused on batch. Let's get the batch processing done right? I mean, in spite of failures, all those things. However, Spark, when you compare that with replacing MapReduce, But it's not really replacing MapReduce. It's basically replacing streaming. It's replacing machine learning iterative algorithms. It's replacing graph processing because of GraphX and all those things. Do you really think that there can be a single computational engine that can replace all these things?
I think it's, we'll see. I mean, I don't know with any certainty. So far we've seen that there is room for special purpose engines, right? We see that in search. I think Impala's going to always be a faster interactive SQL engine than Spark will ever be. It's purpose built for that. The question is, how much do we need general purpose engines versus how much do we need purpose built engines? And to some degree that's an economic question. What sorts of applications do we need so badly and so many of that it's worth investing in a purpose built thing in the way we've done for search or SQL? And how much can we get by with a general purpose engine like Spark? Spark is a much better general purpose engine. Good luck doing effective streaming with MapReduce. What wasn't going to happen? Whereas Spark actually does a plausibly good job. Now it's not as real time as Storm, but it might be good enough for most people. That's certainly what we've seen. That most people don't need 1 millisecond turnaround. They're happy with a few hundred milliseconds, or whatever Spark can do. So I don't think I think Spark is clearly becoming the general purpose engine that's replacing MapReduce because it does a better job of batch and also does other things, which you described quite well. But whether there's room for more special purpose engines, whether there could be two different general purpose engines that have different benefits, I kind of doubt that. I think we're seeing Spark can do a lot of these things pretty well, but we'll see. It's a good. I see a follow-up.
Yeah, if I could just do a follow-up. It's basically, do you think in the Hadoop space there is a space for good enough for all of those things, or best of breed in each of those things?
I mean, there's definitely room for good enough, and there's a lot of things which people write. This is what MapReduce showed us long ago. Is for almost everything you could do with MapReduce, even from the beginning. If you read Google's paper about it, everything you can do with MapReduce, you could do better if you build a purpose-built system. But it takes a long time to build a scalable, reliable, purpose-built system. And so how much do you want to invest in that? And most people didn't want to. They'd rather just do it with MapReduce, even though it wasn't a perfect match. And I think we're seeing the same thing with Spark. Spark is better, but now and then it is worth building a purpose-built system. For graph processing, we'll see. I mean, there are other graph engines out there. I think we're seeing more people do graph analysis in Spark than using those these days. I don't see a lot of activity around those. Although if you're Facebook, who has a graph with 1 trillion edges, they're going to probably continue to use Giraffe because I doubt Spark is as effective as Giraffe for them. But they might be the outlier with a 1 trillion edge graph. We'll see over time if banks and so on and start having graphs that size or not. Yeah.
I didn't know what he was going to ask, so he already asked the question that I was going to ask you, which I had asked you privately. Positioning Hadoop and Spark, I think you've probably said most of the things.
Yeah, I think they're very complementary. Okay. I think there was sort of a sense that I think people used to think, oh, Spark is replacing Hadoop. Sorry, I say Hadoop. I just said Hadoop because I was echoing you. But
sorry,
it's confusing people. It depends on what we mean by Hadoop.
Yeah,
if we mean Apache Hadoop or if we mean the ecosystem. Within the ecosystem, which is I think what we generally mean, Spark is complementing and improving on MapReduce. And because they're both open source, they don't really compete. Right? Open source projects don't really, in many ways, need to compete. It doesn't have to be an either or. People can use both.
But then the question that people want to ask is, when do you use which one, and what are the trade-offs, and so on. On top of it, I also wanted to ask you how you would think of whatever Google has done with its more recent announcements with a year ago, I guess, announcements with Google. What do they call it? Data flow. Yeah, data flow and so on. And also in general, the chaos that's out there with too many non-standard APIs and such, NoSQL plus many other things, and why is it that people don't seem to think that standards matter anymore, and what has changed that's made it irrelevant?
You've got three questions stacked up there. Let's see if I can remember them.
Sorry.
The first had one about how people would know when to use MapReduce versus Spark.
Right.
I mean, I think today if you're writing a new application, you're generally going to use Spark instead of MapReduce. There are a few cases where that MapReduce still does better at very large clusters, in a very long-running job. There's certain cases where it's still better, but I think those are rapidly disappearing. The second question was.
Juxtaposing what Google has done.
Oh, yeah, so the data flow work has now come to Apache. So it's an API for streaming computations. And the Apache project has now been renamed.
Beam.
Beam?
Apache Beam.
Beam, that's right.
Yeah.
Beam. Apache Beam. And I think it's wonderful. So there's backends that use Spark. And there's other backends will be built as the engine behind the Beam APIs, including Google's own implementation, if you happen to be running in their data center on their cloud. So I think that's a great direction. And again, this gives you a standard API. So your third one was decrying the absence of standard APIs. And I don't think that's quite right. I think to a large degree, each open source project has a standard API. Most of these projects are very serious about back compatibility and not breaking people going forward. So we've got a lot of APIs that are standard. And maybe the confusion is we have too many.
Yeah, exactly. I was going to say that.
So that's part of this evolutionary project process. That in order to figure out which systems are best, we need to try some things that are not best and that fail. So it depends on your level of tolerance for experimentation. So Cloudera as a vendor tries to curate these and support only the best, those that have proven themselves. And so if you're conservative, then you're going to work with a vendor and you're going to stick with a stack that that vendor is going to support for 5 years or 10 years or however many years that they advertise. Okay. If you're more experimental, then you'll try other things. And fortunately, there's a blend of both out there. Okay. And the new things do get used and do get experimented with, and we do discover what's next. So I think it can be confusing. Yeah. But I think on the whole, it's for the best. It's better than the alternative of you could have some massive standards body which says this will be the one API for streaming, but it might suck, and there might be a better way of doing it. And trying to improve things through standards bodies is a lot harder, and anyway, I think it's a better process to develop technology.
Hey Doug, Piyush Malik, IBM Global Business Services. Hope you recall our interactions in the past. Question I have for you, we do partner with Cloudera and we work with all technologies. Do you think Cloudera will go beyond Hadoop?
So I don't think of Cloudera as a Hadoop company in some ways. Really, we're an open source big data platform company. So if over time people stop using Hadoop, people stop using HDFS, people stop using MapReduce, people stop using Yarn, we're okay with that. We will survive that because we will move on to whatever the new storage system, the new scheduler, and the new execution engines are. Because we're about building this open source platform and supporting it. I worry about companies, on the other hand, which rather dedicate themselves to a particular project and say, we're the X, I'm not even going to say any project names, and they become that. I think that's a very risky thing, because I think any one project may not last that long. It may be tremendously useful, best of breed for 4 or 5 years. You hope a company lasts longer than that. A company needs to have a long-term story, and I think long-term, this platform is going to continue to change. So does that answer your question?
Yeah, and the follow-up question was Cloudera's position in Apache versus ODPI. Where do you see? I don't know if you are able to comment on that.
So back into the previous one, Cloudera I think has more, is the largest vendor for Spark out there. You know, we're not perceived as the Spark company. We rather just incorporated Spark into the platform, but we have more customers using Spark in production than anyone else out there because of that. So I think it's a good example. ODP is trying to, as far as I understand it, pick a set of components and a set of versions and say that's a standard, is I think what ODP is all about. Now it's picked about 3 components, which we include. I don't think it's solving a problem that people have, I guess, fundamentally. I don't think people are confused about whether to use HDFS, MapReduce, and Yarn together. I think, sure, that's fine. We've got Apache, which standardizes the development of those. They all have good back compatibility claims. So we haven't been very interested in, we haven't heard customers saying, ooh, you need to be ODPI compliant. So I don't frankly see the point for ODP.
All right, well, we are all amongst friends. Thank you.
Feel free to make the contrary argument if you like.
Hi, Doug. Thank you very much for your presentation. I have a question/request, quick background for that. I attended the Spark workshop today, and when I registered for it, it asked me to select where I'm from. And the options given in the multiple choice answer: West Coast, East Coast, Europe, and APAC. I currently live in one of those square states in the flyover country between New York and San Francisco. You mentioned Caterpillar and Peoria. I wonder, by show of hands, how many people know where Peoria is at? Oh, I know. All right, good. So 50% maybe. So I would like to know if there are any plans from Cloudera and the community to start moving inward to try to progress this thing forward. I'm one of the guys who's trying to change a very much legacy company into new ways. We're doing lots of pilots, and it's blowing my mind, honestly, in terms of the capabilities, and we're definitely going to be moving much forward, but I'm having tough time recruiting folks and attracting them into a place like Omaha, Nebraska.
I visited Omaha with Cloudera. I visited Peoria. I visited St. Louis. So we were definitely seeing a lot of adoption in these places. In terms of, people talk a lot about the data science, data scientist crisis. There not being enough data scientists, and the skills crisis in general. I've always felt that the best way to increase skills is organically. People should start playing with this stuff. That data science, and any data scientists in the room, I'm sorry, I don't want to offend you. But I think in a lot of ways, it's what we're providing is similar to a spreadsheet. When spreadsheets came about in the, whatever it was, 70s, 80s, all of a sudden you had people in different divisions of a company who could do some computation over some data and actually test out their idea and say, hey, if we start discounting this here in this market, then we'll start making, and they can make a case and back it with some numbers. And I think there are smart people around companies who have these ideas, and much of the math is fairly simple. You need people who are, know some math, but not necessarily very exotic math in most cases. And companies have these people who know their business, who know what the problems are. We just need to give them access to the data and the tools, and let them come up to speed on that, and then they can help people. And this notion that you need to import people and knowledge, I think, is false. We have the people out there. You didn't have to start training your spreadsheet experts. There wasn't a crisis of spreadsheet engineers, right? I don't remember one. Does anybody?
Valid point, but in terms of recruiting, obviously everybody's eyes are looking outward from the Midwest. But I appreciate your response.
I think there's a lot of smart people in the Midwest.
Absolutely.
So and they can be used. They can use these things.
And by the way, Google's moving in. They're opening up data centers in Iowa. They're moving to Denver. So we do see a lot of that. So I'm hoping to kind of attract more Cloudera's towards those areas. Last question, I have kind of religious debates about that, and you mentioned that in your previous answer. I've heard 3 different versions of Hadoop, Hadoop, or Hadoop. What's the right version?
They're all right. So
I just lost the bet. All right, thank you.
So my son had this yellow elephant toy that somebody gave him, and he made up a name for it. We don't know why he made it up. He just was running around the house and throwing it and doing various things with it, and he called it Hadoop. That's the way he said it. And I wrote it down on a piece of paper, and I had my wife write it down, and we showed each other the pieces of paper, and we both spelled it Hadoop. And then I, over email, say, let's name this project Hadoop, and everybody says, yay, let's do that. And then we get together, and I meet them face to face, and they all say Hadoop, and I say Hadoop. So, I transcribed it badly. I've talked to a linguist, and the way that, what I would have needed to do to get it pronounced correctly would have been to have a double D, like Captain Haddock. Right? That's the sound you want. But I think that would look terrible. And in some ways, it's mostly a written word. It doesn't matter. And people in different parts of the world say different words in different ways anyway. So it doesn't bother me.
But do you say data or data?
I think I say data.
Okay, so the person who basically says Hadoop says data. That's the difference.
That's not
You need ARM servers.
It does.
Hi, Mike Brazzoni from Camp Marketing, from Hardware. Doug, you described the pace of hardware that is enabling the software developments in this space, and then you said in your review, you referred to a cycle. What is the cycle as you see it in this software space? That's the first question, because I distinguished that there might be more than one cycle. We're all very familiar with the hardware enablement cycle, but if there's a cycle in this software space, what is it? And then the second question is for all the entrepreneurs in this room, which I'm sure there are. How many are contract programmers in this room? How many contract program people? Not enough. On this rocket traveling at the speed of light, what does an entrepreneur have to do to reflect that they are not standing still in space? So 2 questions. What is a cycle, and at what speed do I have to run with that cycle to operate at the speed of light?
So I don't think there is a well-defined software cycle. I think we're seeing that some things are going to last longer than others, particularly things lower in the stack. Storage systems will last longer than things higher in the stack, is my guess. Data formats last forever. Once you've got data, people should be really careful what format they store their data in, because they're gonna have to keep reading that format forever, and try to minimize the number of different formats they have. People don't realize this. File systems, you can probably copy things between, but if they're fundamentally different kinds of storage systems, from just a file system to a relational system, then it's probably going to be a lossy transformation, and so you're going to have a hard time moving between them. So the cycle time, I think, is not that well defined. The speed question, I think we're actually, it's not as bad as we might fear, we might think, because the speed is gated by people and the level that we can learn new things. You can't. People could invent lots of things and confuse the hell out of everybody, but then nothing would happen, right? And so when I look at what is happening out there, we're seeing this steady adoption of technologies, and we're seeing this steady agglomeration of new technologies being part of the canon that people are building on and expecting to be around in 10 years. A few years ago, Spark wasn't there. Spark is now definitely there. People can build on Spark and depend on being able to use Spark for another decade or more. In a while, Spark will be like COBOL. It's safely a part of the canon now.
That hurts.
And so I think that saves us from mayhem. That people can only adopt new things so quickly, and we need a certain amount of simplification down to a manageable number of things that a professional can learn and understand. And I think that's what naturally guides this process.
Thank you very much. Appreciate it.
My name is Krishna Kashyap. I have a question. See, I've heard a few companies try Apache Flink.
Mm-hmm.
And some people like it, some people say that they are too early, still in an early stage in the industry. What's your take on it as compared to Spark?
So, I haven't read the source code to Flink or Spark. I haven't written applications using both of them or anything, so I'm going to give you my impression. But again, I encourage somebody who's spent more time to have a difference of opinion. My impression is that Flink is architected probably a little better than Spark. Has some advantages in the way that it works, but I'm not sure that those advantages are significant enough to cause people to use it instead of Spark. Spark has been accepted as the standard. It's sort of a VHS versus beta kind of thing. Beta was better, but everybody started using VHS, and it's like, do we really need to have both kinds of decks? Do we really need to learn both of these? And so I think Flink looks to be, from my opinion, destined for that kind of a fate, for sort of the beta-like fate. That Spark is got the mind share. Everybody's using Spark.
Second question is, see, there are certain applications like telco, network analytics, very high-speed data, 30 billion data points in an hour they catch, and they do so many things with it. Spark may not work. So they did try some Jetstream kind of technologies, and I think Cloudera has invested in Cask, which is trying to work on Apache Tygon, which is probably a telco application. What do you think? Will that be available widely, or what's happening with that according to what you understand?
I'm not sure I know a detailed answer to what you're asking. I mean, we're seeing telcos streaming data they are keeping up, as far as I know, with using Spark and so on. So it's not the rate that you can storing the data is fine. It's how quickly do you need updated results about the data? Do you really need new information about it on a millisecond basis? And then if you do so, then Spark's probably not the right tool. But we see a lot of folks out there in telcos, storing all of their network data using Kafka and Spark, using Kafka to stream it in and Spark to analyze it, Spark streaming.
So there are definitely those use cases are there already, but some use cases, like suppose you want to divert bandwidth on demand from one place to somewhere, for example, for an occasion where a president is coming there or something. The big data, the technologies available are not doing it, and we know that because the telcos directly tell that.
Right.
Yeah.
So I mean, I think there are other options. I mean, Storm is an option, but I haven't been paying close attention to that, so I don't know what the best choice for us are.
My name is Kathy Cheng. I have a question that's probably not fair to ask you, but
I'm okay with unfair.
4 years ago, there was writing out there that talks about how Hadoop is going to be, or big data is going to be a $50 billion market by 2015. Here we are in 2016. And now the writing says 2020 or 2017, depends on where you look at it and how you look at it. How do you look at those numbers, and what do you think is the true potential of Hadoop, or Hadoop?
I see a lot of crazy numbers from analysts, and what I see from Cloudera's perspective is very steady growth. We've been, roughly doubling. It's probably a little less than an annual doubling now, so it's slowing a little bit in number of new customers. Our existing customers tend to increase the size of their clusters less than every 12 months. They're growing. They tend to renew at a very high rate, I don't know, 80s, 90s percentage when their subscription is up. So if you put that together, we see very steady exponential growth in the size of the market. And as I said earlier, I think we're growing at roughly the pace, on one hand, that people can learn the technology, on the other hand, at the rate that the technology improves and becomes easy to use and becomes applicable. So, for example, a few years ago, we worked with MasterCard and got a system which was certified as PCI compliant. It's the I forget what PCI stands for, but it's the credit card industry's security compliance standard.
Payment card industry.
Payment card industry, thank you. And since then, before then, it was hard for the credit card industry to use Hadoop in a lot of applications. Now it's much easier, and so it's opened up this market. We see this in payment cards, companies around the world now able to use Hadoop. So it's not just getting more people trained, it's the technology getting more mature. But both of those things are happening at pretty steady rates, and we're seeing this steady adoption. We have customers in the majority of big companies in the US, and soon probably the majority of big companies around the world. But those tend to be small applications at the beginning. It tends to be one application, relatively small cluster, but they grow steadily. And I see that continuing for some time. So in terms of billions of dollars, I don't know what the market size is this year or next year. But I think it's pretty clear it's growing very quickly. It's been growing steadily. There hasn't been any crazy oscillations in this growth or drop-off, a precipitous drop-off in the growth. And if you look at the growth in traditional enterprise systems, there isn't a lot. If you look at Oracle and Teradata, those markets seem fairly saturated. And yet I think there's a good case to be made that the IT market is growing, will continue to grow. People are going to continue to store and process more data to better understand and improve their businesses. I think it's clear. It's happening in industry after industry, and most industries are in a very early stage of it. And so if you buy that, there's going to be growth in the software market for some time as that happens.
So obligatory second question. How do you...
Limited time, so please if you can refrain one question.
Okay.
Thank you.
So I noticed the first woman up here, and I got cut off here.
Each of you, only one more question. Thanks.
Hi, my name is Mahesh. Wanted to ask you if you see any gap in terms of security in Hadoop, and especially in context of billions of devices coming online as part of Internet of Things. Can you talk or address that?
There's a lot fewer gaps than there used to be. There used to be no security in Hadoop. We've added, originally added authentication, added access controls, first fairly coarse. They're getting finer and finer grained, added encryption of data at rest, data on the wire, and all this is continuing to improve. I mean, as new components show up, they tend to be fairly insecure. Spark was, a year ago fairly insecure, is now getting to be fairly secure. I think we're not quite done in getting Spark to be fully secure. So it's a process. Depends on the application, and I think it's something people need to look at closely. There are a lot of regulated industries which are using this set of tools and trust it to be secure. So I think we've made a lot of progress. There's certainly more to be made. Just as Apple learned that there's more to be made, more progress for them to make too.
Thank you.
Hello, Doug. Thank you for the time. I'm a systems architect and I've spent considerable time in data warehouses on the relational side. Thanks to Hadoop, I've moved a couple of them into Hadoop. But my question is mostly in the usability area of Hadoop. Like, I've had a couple of occasions where I have to tell them that, or tell people that Hadoop is a little harder to use, but it's more powerful. I want to ask your take on Cloudera's focus for this in terms of making Hadoop easier to use. And in connection to this, actually, especially in the data science area, it becomes really hard once you build an application with A/B algorithms. In fact, Google has a paper on this saying machine learning actually goes against standard architectural practices. I just wanted to understand what.
So we're certainly working on making things easier to use. We've been investing in Hue for years, trying to give users a graphical tool to access all of the tools. We recently, just this last week, or week before last, announced we've acquired a company that's building a workbench for data scientists. We're trying to expand the ability of people working in R and Python. We're making a number of investments there because that's where a lot of data science work is. So it's an ongoing process. On the other hand, we're probably never going to be at the top of the stack. We hope that people are going to build things that are really easy to use things that are sort of the self-service systems are probably going to be built by other people. We want to provide a platform primarily for developers and data scientists, and the end user applications are probably going to come from elsewhere, and those are the things that are going to be easiest to use.
All right, thank you.
Sure.
Hi. Question on distributed computing. We've been trying to crack multi-threading and cluster systems and parallel processing. Can you kind of reflect on the last 10 years of how far we've come to understand distributed computing and parallelization, what we're good at now that we haven't been and where we could be better?
So I remember, throughout my career, the distributed computing was always the promise of the future, the way to scale. And I think until those Google papers, it wasn't widely used. It's used some in scientific computing, but not much outside of that. I think what struck me when I read Google's paper about MapReduce in particular was there's a fairly simple approach. It's not sort of fully general peer-to-peer distributed computing. Rather, it's centrally coordinated distributed computing. And there's a paper that Google published, I don't remember the exact reference, I could probably find it, a few years more recently, saying that that's a characteristic that they found successful again and again. That's a theme they found in the systems that they deploy, is that the processing of the data is distributed, and the storage is distributed, but the control of the system and the control of the application is centralized. And that is a model that again and again they find is manageable. You can implement it. It may not be easy to implement as a particularly a single-threaded application, but you can do it, and that and you can understand it, you can optimize it, and build usable systems. So I think that's the plateau we're at now, and I think that's more or less the trend we're seeing across the Hadoop ecosystem. But I think people are really using distributed computing now in a big way, whereas they weren't 10 years ago. And so it has brought us to this next level. Whether we'll someday move beyond that, I can't say.
Hi Doug, my name is Sanjeev Srivastav. As you look at your customers who are getting in this area of big data computing, can you guesstimate the amount of time it takes for them to get from a POC stage to having these systems fully in production? And the reason I ask is because I've seen a few instances where fairly large companies have spent a year or two or more of setting up data lakes and such, and they're still not in production.
I think it varies a lot. So I think it can be as little as a few months. and perhaps as much as a few years. I tend to not particularly like the term data lake because it sort of implies this model that you build a big place where you load all your data and then you figure out what you're going to do. And I think that's not necessarily a recipe for success. I think what we see people who succeed are they have an idea, they do a POC, and they decide does it work or not. And if it does, then they deploy it. If it doesn't, then they wait around and find another idea. And then once they're up in production, then they start thinking about their second application and whether it overlaps in the data that it uses and the tools that it uses with the first one, and whether they can just grow the cluster and add the second application there in place. And they start to grow organically, but always guided by finding something that works and gives them value. And not just sort of saying, oh, we need to modernize our data architecture, we're going to just throw everything into a data lake and magic will happen. But to be very grounded, and also to start with simple things. The people tend to want to think, oh, we're going to do this predictive analytics thing with machine learning and do that, they read a lot of blogs and think that's the future. When in reality, it's better to start with something like, we're spending a whole lot of money doing ETL in our Teradata appliance. We could do it a lot cheaper in a Hadoop cluster. Let's do that and save a lot of money, and in the process we'll learn how to use Hadoop. We want to load 5 years of data into our data warehouse, but we can't. Let's say put 5 years of data in a Hadoop cluster, run the same algorithms. That's a sort of variation on the same cost savings. You try it, fairly straightforward. You know what you're going to do with it. You can see the value fairly readily. Other one that we see a lot of and recommend as the first one are these sort of customer 360 kinds of things. You've got a bunch of silos. You've got a classic one is banks, where you've got retail banking. You've got car loans. You've got home loans. You've got investment. And in each of these, you might have a couple of different operations because the bank has grown through acquisitions and they've never merged their back-end systems. If you could dump all these into one data set, then you can get a complete picture of your customer, decide what products should you offer them, what products shouldn't you offer them, and things like this. And that one, the telcos can do the same kinds of things. They've got different kinds of data sets and different silos. They can bring them together and find out things about their business that they can directly use to improve it. And those are also things you can easily experiment. You can sample the data. Can we get some insights by combining these data sets that we didn't have before? Answer that question, yes, deploy the system. Fairly straightforward. And not using a lot of exotic techniques. So we very much encourage people to go with those sort of conservative first applications and then grow from there. And I think if you try something more speculative, then you might be frustrated for a while. Because it does take a while to get used to it and to find those advanced applications.
Thank you. Hi, Doug. Question on, since now that the RAM's getting a lot cheaper, so there's always this debate about the scale up and the scale out architecture, right? And so scale up, then I don't have to worry about distributing, and I could just have everything in a terabyte RAM machine and do all my processing. And this is more so recently because with the advent of deep learning, all these techniques, and for me to now have a parameter server, distribute it and send all these computations just makes my life, it causes a lot of pain. And really like doing that in Hadoop or in Spark ecosystem is harder. There's not, we have to go through like 90% of the time just adjusting my parameters and worrying about distribution, but not my algorithm. So what's your take on, if like these RAMs getting cheaper and I could scale up my architecture, especially for deep learning or more sophisticated machine learning, I could do all of that in a single box and do all these stuff.
I mean, I think if you can do it in a single box, then do it in a single box. You shouldn't be using distributed things unless you need them. The one argument against that is if you expect things to grow and you're not convinced you're going to continue to be able to do it in a single box, then you might want to use tools that will be able to scale to distributed solutions.
But then, especially for deep learning, the amount of computation that I would have, so definitely would move out of my CPUs and getting into the GPUs, and it really requires very specialized. So how do you, going back to the next 10 years, is there something in the Hadoop where now we could effectively use these GPUs and parallel computations in combination with all the in-memory data grid and get to the next level? So that was just want to know your thoughts on what would be that.
I think GPUs can do phenomenal things. We've seen a lot of machine learning that can use those. But on the other hand, it seems like the bulk of what people are building that I see, the bulk of the software, doesn't easily move to a GPU. And so there's still a lot of demand for conventional processors, and I think there always will be. It sort of comes back to this general purpose versus purpose built. I think in order to use GPUs, you need to have identified a fairly narrow problem that you're willing to optimize to that, and there's going to continue to be a lot of general problems which people haven't optimized to go on those. It's my hunch.
Thank you.
Gentleman in the green shirt, last question. Go ahead.
All right, thank you. Hey, Doug, my question is, let's say I'm a student or I work for a company that does not have access to the massive parallel computing that you're talking about. My question is, how do I get involved? I know Apache Hadoop would be the next big thing, or it is already the next big thing. As a small fish, how do I get involved in this big revolution, I would say?
So you can download VMs from various vendors that have all of the software loaded, and you can run it on a single workstation. It all works. It doesn't necessarily, doesn't work that fast on a single machine, but it works fast enough that you can get a sense of how the tools work. If you have a larger data set that you want to do some experiments on, then you can pretty quickly deploy things and run things at Amazon or Google or Microsoft in the cloud. If you don't run it too long, it doesn't cost much. So we see most startups, for example, these days start in the cloud. Most people who are experimenting and doing POCs do those in the cloud. Building an on-premises cluster is a big proposition, a big investment, and people tend not to do that these days right away. It's pretty easy to do something in the cloud, but also you can just start on a workstation.
Thank you.
Thank you, Doug. Please join me in giving a big hand.